Hello friends, welcome to Learner's Planet. Friends, this is our first session for the topic surface area and volume. Right? In this session, we are going to discuss the formula and concepts related to the cylinder, cube, cuboid, cone and other 3D figures. Right? And the basics you might have already learnt in your junior classes. Yes, so just have a quick recap of the basic formula of this cylinder, cube, cuboid and cone. Right, so let's begin this session. Have your paper and pen with you so you could do the revision right with me. Now first we will be taking cube. So this is a cube. Now it's a 3D figure. These points are known as vertices. These are edges. These are this, these are faces. Okay, so a cube has 6 faces. 1, 2, 3, 4 and 4 at the bottom. 8 vertices and 1, 2, 3, 4. 4 at the top, 4 at the bottom and 4 at the side. In all 12 edges. Right, so this is what a cube. Right, all the 6 faces of cube are square in shape. Right, now we try to find out the area and volume of cube. Right, now area is what? See, as I've already told you, all the 6 faces are square in shape. Suppose this length is L. Now if it is L, it has to be L because it is square in shape. So area of one face will be L square, right? Because it is a square. Now there are 6 faces as I've already told you. So the total surface area will be L square into 6, that is 6L square, or we can say that is total surface area of a cube, right? Area of one face is L square since it is in square in shape and there are 6 squares, or we can say 6 faces in the cube. So the total surface area will be equal to 6 times square area of a square. So that is 6L square, right? Similarly, we can find out the volume. Volume is base area into height. Right? So for any straight figure like this, you just find out the base area, find out the height, that will be the volume of the given 3D figure. So base area will be what? Since the base is square, so base area will be L square. Now height, since this is a square, height will also be L. So precisely it is L cube, that is the volume of a cube. So surface area is 6L square, that is total surface area, volume is L cube, and area of each face is L square. Okay. Next is cuboid. Same, 8 vertices, 6 faces, but all of them see 3. There will be 3 sizes of the faces. I just explained. Then 8 vertices and 12 edges. Right, now this is length, this is height, and this is breadth, or we can say this. Right, so this base is rectangular, this is a rectangle of a different size. This and the base, both of them are having the same size, length into breadth. This is also length into breadth. Area of this face will be height into breadth. Okay, similarly area of this face and area of this hidden face will be breadth into height. Right, so there will be 6 faces, 2 faces, area will be length into breadth, top and bottom. So total area of these 2 faces will be 2LB. Okay, similarly one this and one this, 2 rectangles will be there, or 2 faces will be there of area B into H. Right, so 2BH. Similarly we have this particular face, that is, this is L and this is H. this and the hidden one, the third one, right? So that's L into H. So 2LH. So 2 faces 2LB, 2 faces 2BH and 2 faces 2LH. So the total surface area will be 2 times LB plus BH plus LH, right? That is the total surface area of a cuboid, right? There L, B and H, all of them are different. If L, B and H, all of them are same, then it will be converted to a cube. Sometimes B and H are same and sometimes they are not, right? So precisely this is the explanation of this formula. After that we consider volume. Again volume is same, that is base area into height. Okay. Now base area is what? L into B. And height is what? H. So volume of a cuboid is LBH. Right? Now next we have is cylinder. You might have seen the talcum powder box that is actually cylindrical in shape, right? Now why I have drawn this rectangle over here? See, if you roll this rectangle, it will be converted to a cylinder, right? If you roll this across this line, then you'll be getting a cylinder like this, right? Now the various terms related to cylinder are, just listen to me carefully. So this is circular surface, right? So it is the radius of the cylinder, right? This from this point to this point, that is the center point of the top surface and center point of the bottom surface. The distance between them is height of the cylinder, right? And again this is radius. Now this round surface, that is actually known to be curved surface, right? Now how do we find out the area of a cylinder? Just listen to me carefully. There are two types of surfaces in a cylinder. This is actually curved surface and top and bottom surface, right? Top surface is circular, bottom surface is circular. Bottom surface is also circular and this is curved surface, right? Now what is curved surface? If you roll up this rectangle, you'll be getting a cylinder, right? That is a hollow cylinder, right? If nothing is there. So it'll be, if you roll up this paper, you can experiment it. You just take a rectangular sheet of paper and then just roll it, you'll be getting a hollow cylinder, right? So actually this is what length of the rectangle and this is what breadth of the rectangle, right? If you roll it up, this length is converted to this circular surface, right? And this breadth is converted to height of the cylinder, that is this, right? So actually area will be what? If we talk about a rectangle, the area will be L into B, and similarly if we talk about the same thing is converted from this to this, so area will remain same. Area in this case will also be L into B. But here L, what is the definition of L? That is actually because this L is converted to 2 pi r, right? Because this is a circular surface, right? So this L, if you are rolling it, it will be converted to 2 pi r. That is circumference of a circle. So this length is nothing but this way. So if this length is converted in this, so L is converted to 2 pi r, that is the circumference of this circle, right? So that is actually curved surface, that is the bottom surface, right? And area of this rectangle is L into B, so area of the cylinder will be what? 2 pi r into H, right? That is the curved surface area. Curved surface area, that is L into B. In this case it is 2 pi r into H, right? So that is curved surface area of a cylinder, right? And you should be conceptually clear how a rectangle is converted to a cylinder and how this formula of area we have derived. Now if we talk about the total surface area, right? Total surface area. Right, this is just the curved surface area, that is 2 pi r h. If this cylinder has a lid over top and bottom, if it has lids, Otherwise, this will be the area, right? If it is a hollow cylinder, then there is no other area. If the cylinder has any lid at the bottom and the top, right? If it is having just a lid at the bottom, then you can see this lid must be circular in shape, right? So if this is circular in shape, the area will be pi r square, right? So that is the area of the bottom lid. Similarly, if the cylinder has top lid also, again it will be circular, so area of that will also be pi r square, right? So this is the total surface area of a cylinder when it is closed from both the sides. This will not come if it is open from one side, and if it is open from both the sides, then only 2 pi RH will be area, right? So total surface area is 2 pi RH plus 2 pi r square, or I can take 2 pi r as common, and inside there will be r plus h. That is the total surface area of a cylinder. That includes bottom and top, both the surfaces. Okay, and you should be conceptually clear. If it is open from one side, only 1 pi r square will be there, and if it is open from both the sides, then only curved surface area will be there. Only if it is closed from all the sides, total surface area will be counted. Right? Now let's discuss about the volume. Volume is again base area into height. Now what is the base? Base is circular, as I have shown you over here. So what is the area of a circle? That is pi r square. So that's the base area into height, that's h. So volume of the cylinder is pi r square h. Right? So the formulas are very simple, and the derivation is also in fact very simple. Just be logical, be clear with all the terms, right? All the expansions. Now next is cone. You might have seen the ice cream cone that is in this shape, right? Again, the basics, this surface that you can see, this surface, that is actually curved surface, right? This is the flat scene I have shown you over here, and this is the curved scene, right? So this surface is curved surface, and this, it's a circular surface, and this is slant portion, right? So this is known to be the radius of this cone. From this point to center of the circular surface, it's the height of the cone, and this is known as the slant height, right? S-L-A-N-T, slant height. Right? Now H, R and L, they form, they are like sides of a right angle triangle. So h square plus r square will be L square. That is a Pythagoras theorem, right? Now the different areas in this case will be curved surface area and total surface area, right? Now the curved surface area is pi r L, right? L is slant height over here, and that is the area of this surface, right? And bottom is definitely circular, so the total surface area is pi r square, that is the area of this circle, and plus curved surface area, or we can say pi r plus L, right? So that is the total surface area of a cone. If cone is open, then only curved surface area will be calculated. If cone is closed, that is, if there is a lid on the top of the cone, then the total surface area will be counted, that is pi r plus L. You should be conceptually clear, as I told you earlier also, which surfaces are being counted, that you need to be clear. Okay, and H, R and L, these are the three sides. Okay, so they will be forming right angle, and h square plus r square will be L square, right? Now that is the area. Now we count volume. Volume of, since this is a slant figure, the volume will be 1/3 of base area into height. Now base area is what? Base is circular, so base area will be pi r square, and height is h. So the volume is 1/3 pi r square h, right? So this is volume, this is total surface area, and this is the curved surface area of a cone. Okay. Now we have sphere. Your cricket ball, your tennis ball, all of them are spherical in shape, right? So the total surface area will be 4 pi r square, and volume of a sphere will be 4 upon 3 pi r cube, right? Total surface area and volume, right? Now if we talk about the hemisphere, I just draw a hemisphere for you. This is what a hemisphere, right? So this is what the radius and this is what the radius. So if we talk about volume of a hemisphere, that's hemisphere, volume will be just half. So it's 2 by 3 pi r cube, because capacity of hemisphere will be halved. But if we talk about the surface area, now listen to me very carefully. Surface area of this outer surface will be half of that, because the total surface area is 4 pi r square. So outer surface will be 2 pi r square, right? But again, if there is a lid on the top surface, then this lid will definitely be circular. Then the area of circle will be pi r square. Right? So the total surface area of hemisphere will be 3 pi r square. And when it will be 3 pi r square? When it is closed from the top. That means there is a lid over here and the lid is circular. So the area of this circular lid is pi r square. That's why the total area is 3 pi r square. If there is no lid over there on the top, then the area will be only 2 pi r square. Right? That is the surface area. Okay, so be careful about both the things. Now friends, after this sphere, let's discuss about a frustum, that is frustum of a right circular cone, right? If we have a cone like this and if it is cut horizontally, I'll just show you, if it is cut horizontally like this, then it is converted to a smaller cone and the remaining portion is a frustum. Okay, so let's discuss the frustum in detail. Now friends, here I have given various pictures of frustum of a right circular cone. See here, this is the complete cone, and if it is cut horizontally, that means horizontal to the base, then this top portion is again a smaller cone and the remaining portion, that the bottom portion, is actually frustum, right? So this is frustum and this is smaller cone. So this is the frustum, right? You can see the various figures, images over here. This, right? Now surely a frustum of a right circular cone has two unequal flat circular surfaces and a curved surface, right? This is a circular surface, this is a circular surface, but they are unequal, and this, the dark green color, that is the curved surface, right? Now what will be the height from this center point to this center point? This is the height of the frustum, okay? And from this point to this point, that is actually slant height that I have shown over here. This is the slant height, and from this point to this point, that means center of this circle to center of this circle, that is the height of the frustum, right? So, and here you can see this is the radius of this bigger circle and this is the radius of this smaller circle, that is R1, and this is R2, right? Now let's see, how do we calculate the surface area, the total surface area, the curved surface area, and the volume of a frustum of a right circular cone. Okay. Now we have this frustum. Here, these two circular surfaces, the radius of this circular surface is R1, this is R2, that the radius of the smaller circular surface, and distance between these 2 points, that is center of circles, is H, that is height of the frustum, right? And we assume that the slant height from this point to this point, the slant height of the frustum is L, right? Now what we do, we complete this figure by making it to a cone, by completing it to a cone. So it's something like this. Okay. Now let's complete this figure. Here I suppose this point to be A, this point to be A dash, this point to be B, this point to be B dash, and this point is suppose V. I assume the center of the circle to be O, and here it is O dash. Now from this point to this point, that is height of this cone, this frustum. So that's also H. Now you can see this length is R2, this complete length is R1. From this point to this point it is R2, right? So this length, that is from this point to this point, this length will be R1 minus R2. This total length minus this length, that is R1 minus R2. That is this length. Okay. I assume this point to be suppose L. Now friends, the important thing over here is this triangle VO dash B dash and VOB. Both of them are similar to each other, right? Because this line is parallel to this line, right? So VO dash B dash is similar to VOB. VO dash B dash is similar to triangle VOB, right? If the two triangles are similar, obviously their sides will be in the ratio. So the side of this triangle is VO dash by side of this triangle is VO is equal to R2 by R1, and the third side is this total length. I assume the total length VB to be L1, this total length. So for this triangle, this length will be total length minus this length, right? Now B dash is L, that is slant height of this frustum. So this length will be total length minus this length, that is L1 minus L, and the total length is L1, right? So the sides are in proportion. Similarly, I assume VO, that is the total height of this cone, to be H1, right? So VO dash will be VO minus O dash O, right? So VO is H1 minus O dash O is H by VO is H1, right? So this is the relation that we have got. So when you are having a problem based on frustum, instead of mugging up the formula, what you can do, you can put up this triangle similar to this triangle. That means you can put up the sides in ratio, right? After that, whatever the information is given to you, just put it up and find out the remaining quantities, that is R1, R2, whatever is the left. Okay. So for that, you don't need any formula to mug up, right? Now we calculate the volume of the frustum of the cone and the surface area, that is lateral surface area and the total surface area of this frustum, right? Now volume of cone will be what? Volume of this frustum will be what? Volume of VAB minus volume of VA dash B dash, right? So I write volume required, that is volume of frustum will be equal to volume of this cone VAB minus volume of cone VA dash B dash, right? Now you must be knowing the volume of the cone, that is 1 upon 3 pi r square h. So I take common as 1 upon 3 pi r square. That means for this VAB, r square will be r1 square, and h will be the complete height VO, that is h1, minus here for this it is r2 square, and the height will be this height, that is the total height minus this height, that is h1 minus h. So if you simplify it, it will be 1 upon 3 pi r1 square h1 minus r2 square h1 minus r2, plus r2 square h1. Sorry, this is h1 minus h only. Okay. So that is 1 upon 3 pi. So that is h1 r1 square minus r2 square and plus r2 square h, right? Now it depends, whatever the values are given to you, according to that you need to proceed. So I will not tell you how to substitute the value from one relation to other relation. That you can do on your own, right? Depends upon the quantities which are given in the question. Okay. So this is precisely the volume of the cone and how to volume of this frustum. So how would you learn that? The volume of the entire cone minus volume of the smaller cone. That's it. That is the volume of the frustum. Volume of the cone is, that's very simple, 1 upon 3 pi r square h, and volume is the smaller cone, whatever the quantities are given, according to that 1 upon 3 pi r square h, right? So precisely r and h are unknown for both of them, right? For the smaller cone and for the bigger cone. So if you have that, you can find out the volume of this frustum. So that's pretty simple. No need to mug up any formula. Now let's find out the surface area of this frustum. Now suppose we have to find out this curved surface area of this frustum. Again, you can very well see from this entire cone, the curved surface area of a cone is actually pi rl. So for this entire cone, it will be pi r1 and the total length is l1. This is the curved surface area of this bigger cone, right? From that, if you subtract the curved surface area of this smaller cone, that means this complete area, if it is deducted, then we'll be getting the curved surface area of this frustum. So that is pi, radius is r2 and height is the complete height minus this height. So that is h1 minus h. So this is what? I'm sorry. It's a slant height. So that's L1 minus L. So this is what the curved surface area of this frustum. Now suppose you have to find out the total surface area. That means this curved surface that we have already found out plus area of the smaller circle, that is pi r2 square, plus area of this bigger circle, that is pi r1 square, right? So precisely you don't have to learn even a single formula to find out the volume or area or maybe curved surface area of a frustum, right? If you are logically clear that both the triangles are similar to each other, just put up that condition and you must be knowing the basic formula of cone, then you can find out each and every relation related to frustum, right? I hope you are clear. Now friends, I take a practical example. I just take a question based on where we have to find out the volume of a frustum. So the question given is, draw a frustum over here, just wait for a moment. Okay, here it is given that the radius of the bigger circle is 28, radius of this smaller circle is 7 and height of this frustum is 45, right? As I already told you that you no need to mug up the formula when you have to find out the volume of this frustum. Now what you can do, you can, even you don't have to do in fact, but for explanation I'm just doing it. I just complete it into a cone. Now this is 1/4 of this. That means this length should be, or I'm sorry, this length, because this triangle is similar to this bigger triangle. That means this length should be 1/4 of the total length, right? That means this must be, the ratio of this and this must be 1:3. Then only this length will be 1/4 of the total. If it is 45, it has to be 15, right? So you got this length. That means you got height and radius of the smaller cone and height of and radius of the bigger cone, right? Now what you have to do to find out the area, volume of this frustum, you find out the volume of the entire cone and then deduct the volume of the smaller cone. So that is 1/3 pi Now r square h, right? So r square is 28 into 28 into h is what? 60 minus r square h. So 7 into 7 into h is what? 15, right? Now we just solve it simply. You can take common. 7 into 7 into 15 can be taken as common. So that is 4 into 4 into 4 minus 1. So that is 64 minus 1, or I can say 63. 621 and into 3. Just multiply all these figures and you'll be able to get the volume of this frustum, right? So precisely you don't need any formula to find out the volume of the frustum. Similarly, you can even find out the curved surface area and the total surface area of this frustum, right? Because this length will also be in the ratio. Now this is 15, 7. Obviously, these three will be in Pythagorean triplets. So you can find out this. So that's 15 square plus 7 square. So that is 225 plus 49. Will be an odd figure because in this particular question it was not asked to find out the curved surface area. So don't mind, but this way you can find out the curved surface area of this frustum. Okay. Now in this question, the slant height of the frustum is given as 4. So that means this length is 4 and the perimeter of circular bases are 18 centimeter and 6 centimeter. That means 2 pi r1 is 18 and 2 pi r2 is 6. Okay. So precisely r1 is to r2 is 18 by 6, or we can say 3 is to 1. Now I complete this. Now r1 is to r2 is 3 is to 1. So I assume this to be 3k, then this must be k, right? Now this length is 1/3 of this. That means this length will also be 1/3 of the total length, right? This length is 1/3 of this. So this length, that is the slant height of the smaller cone, will also be 1/3 of the total cone, the bigger cone. That means the ratio between this length and this length must be 1:2, right? So if it is 4, it has to be 2. Now 2 is 1/3 of the total length, that is 6. Okay, so that is the slant height of this smaller cone. This is the slant height, that is 6, the slant height of the bigger cone. Now we have to find out this curved surface area of this frustum. So curved surface area of the bigger cone, that is pi into r, that is 3k into L. L is what? 6. Minus curved surface area of the smaller cone, that is pi k into 2. So pi into k is common and it is 18 minus 2, that is 16. Okay. Or precisely what we can do is pi into, instead of this radius we can put up the value of r1, that is 18 by 2 pi, and this is 6 minus this is pi, this is 6 by pi, 6 by 2 pi into 2. Okay. So that is 54 minus 6, 48 units. Whatever, if it is centimeter, then it is centimeter square. Right? So without using any formula, we just have put up the concept of similar triangles over here and we have calculated the curved surface area and volume, both of them for a frustum. Right? If you are asked about the total surface area, then r1 and r2 are already there. Just add up pi r1 square plus pi r2 square. You will be getting the total surface area of this frustum. Right? You just have to add both the quantities into this 48. That is the curved surface area. Right? You can simplify this calculation by taking the things as common, and you can eliminate the step. Actually, it is not at all necessary. It's just pi r1 L1 minus pi r2 L2. right? That's it. That is the curved surface area of the bigger cone minus curved surface area of the smaller cone, right? So friends, in the next session, I'll be taking some more problems based on 3D figures like pyramid, frustum, and other 3D figures, maybe hexagonal pyramid. So I'll see you in the next session once again. Bye-bye. Do revise this session before you come for the next one. Bye-bye.